All right, today we are talking about the same kind of recursive formulas, except we're trying to do growth and decay with them. I think you know that growth, a graph of exponential growth would look something like this. And a graph of exponential decay, some people think that it looks like this. That's not right. Exponential decay actually looks like that. It starts out faster at the beginning, and then it ends up going slower and slower. So exponential growth, this is the growth, this is the decay. Now what does it look like in a equation? Well, if you go like this, u sub 1 equals 1,000, we have about 1,000 moose in Minnesota. Do you know that the moose population is actually in danger and it's been going down? It's one of our animals that we have to worry about. Wolves, on the other hand, was in danger, but now it's been growing pretty dramatically. There's more and more wolf packs running around in Minnesota. And actually, that's one of the things that's causing the moose population to go down. Now, they don't know how much to blame the wolves for it, but almost all of the kills that they've found haven't necessarily been killed by the wolves, but they've been eaten by the wolves once they're dead. So it's really hard to know if the moose are being killed by the wolves or if it's just the dying by natural causes and whatever. There's also this tick that is causing the moose to get really sick because they get so weak from being drained by these ticks. Can you imagine having so many ticks on you that you die from it? And you can't get them off because you don't have like opposable thumbs, and you got hooves, and you can't like reach your back with your hoof, and so it's a pretty rough way to go. So they're trying to figure out a way to help our moose population, but not all of them have these ticks, but some do, and some have them really bad. It makes me itch just thinking about it. Okay, anyway, if you say this, you have started on the right track, and then I'm going to show you a way that I want you to do all these growth and decay problems, and I'm telling you, if you do it this way, you have a much better chance of getting good grades in the test. I know there's another way you can do it, but I think you'll come to understand why I think this is a good way. If I want to have growth of 5%, I do not want you to type 1.05, even though it's right. I want you to say 1 plus 0.05. Here's why. If it's 5% growth, here's what people mess up. If I say, what factor gives you 5% growth, 1.05 is correct. Which part is the growth on it, though? The 0.05. So people will often say that's 105% growth by accident because they see the 1.05. If you see them separated like this, you're much more likely to do it right and say, oh, it's 5% growth. The other kind is decay, and let's say something's going down 14%. Then I'm going to have you do 1 minus, because it's decay, 14%. And the really common mistake there is people often just put 0.14 because they think, oh, I'm supposed to use a decimal. I'm going to use a decimal for 14%. What they really are doing is 1 minus 0.14, which is 0.86. So if you have 14% decay, you should really be using a decay factor of 0.86. And people tend to just say, oh, so I should put a 0.14 right here times 0.14. Now that wouldn't be 14% decay. That would actually be 86% decay. So if you want 14% decay, you go like this. 1 minus 0.14. All right, now let's put that into the calculator. Everybody grab your calculator, and we're going to start with, you know what, instead of u sub 1, I think we should start with u sub 0, because anytime you're given a real-world problem, u sub 0 usually works better. That way we can say, after 1 year, how many moose are left? After 2 years, how many moose are left? If we start with u sub 1, after 1 year would actually be u sub 2, not u sub 1. It can be really confusing. So this number right here, you pick it based on, if it's a real-world problem, start with 0. If they want you to tell them the 10th term, start with a 1, because that way the first term is the 1, and that makes sense. Second term would be u sub 2, etc. So this is a real-world problem. We're going to put a 0 on there. All right, so now, in your calculator, we should then have a 0 right here for this first line, 0. And then u sub n minus 1 times 1 plus, and actually let's do decay rate of 14%. So we're going to go 1 minus 0.14, end parentheses. You get how that's going to take our 1,000 moose. Let's make this 1,000. I actually have too many zeros in there. Sorry. 1000. Our 1,000 moose, and it's going to make it go down 14%. Again, in here, I'm going to arrow over so you can see I have 1 minus 0.14. Okay. Now, did you know you can graph these things? Everybody hit graph. And then just, yours is not going to look like mine because your window is different than mine. So let's get your window to look like mine. Everybody go to your window, and your n min and your n max, we started with the 0, and the max is, we're going to do like 20 years worth of data. So it goes from 0 to 20. Counting by 1 is all good. The x min, that means when you actually make the graph, do we actually need negative x's, which would be negative years? No, we could have it from 0 if we wanted to. So I could make that a 0. And that's up to 20 years. Then, you see how there's an arrow in the lower left-hand corner? That's a hint that there's more stuff you can't see if you arrow down. Your y's aren't here yet, so now there's the y's. Why did I go so high on the y's? Because we wanted to see at least 1,000, which is where our population started. The reason I went with 2,000 is because then I can do growth on the graph later if I want to. Because 1,000 gets us high enough to be where the moose population starts. And then if I allow it to go up to as high as 2,000, it allows me to show some growth. Once you got all those numbers in like that, and again the last one there was the Y max needs to change to 2,000, you hit graph and it'll look like this. That's our moose population dwindling away. We're hoping we could figure out a way to stop it. The tick problem is hard to figure out, but it could be something as simple as, and I know this sounds completely ridiculous, but you ever heard of flea collars? That kind of thing can work. Okay, so we seriously might go put a whole bunch of flea collars on our moose, which will cause them to not have ticks, or at least not as many. In a really ideal world, you'd probably put them around their legs because the ticks climb up their legs too, not just around their neck. And so they might look completely ridiculous but be alive. So now there are some problems with dropping the moose because you don't just walk up to the moose and say, "Here, moosey, moosey, I'm going to put this collar on you." They don't tend to like that very much. So you have to give them shot like a tranquilizer. So they usually have to tranquilizer gun them, and then it's sad but true that, like, I don't know if it's like 1 out of 20 or so will die because complications from the medicine that puts them out. So when you see something get tranquilized, there's actually like a 5% chance that thing's never going to get up again. They don't usually show you that part on the wildlife shows, but when you tranquilize something, is not a guarantee that you're going to do it right, or that it's not going to take it wrong. So just the stress of it, sometimes the animal gets really stressed out from the experience. You know, I can understand that. It's not too often that anybody tranquilizes me and then like tags me and then walks away. Might be a little stressful. Okay, anyway, if your graph is not looking like this, try to fix it. Ask the kid next to you or whatever. But I want to come around and make sure yours looks like this. So have your graph up, looking like that. If it's not, hurry up and fix it. I'm going to pause for a second while I do that. Okay, everybody go back to your y equals screen. And this time, I want to talk about growth instead of decay. Something that has been going well in our state is your wolf population has gone up pretty dramatically. So let's start with, I do not have the exact numbers on this, but let's say that we had about like 50 or so. So let's go down to 1,000 to make it 50 for our wolf population. and it's been growing, let's say 25% per year. So then we arrow over here to 1, and we don't want to say minus anymore, or that won't be growing. So we say plus. 1 plus, and then we're going to say 25%, so 0.25. And let's see what that graph looks like. Okay. You see how the graph is going up pretty dramatically now? All right. I'll put this back up in case you got lost in what's going on here. All right, now I want to change one more thing. Let's say instead we start with the year. You know how I was saying we could start with a 0, or we could start with a 1? If you look at this formula right here, this could be the year 2014. Let me show you why that's a smart thing. Okay, let's go up to the top. Everybody change this to the problem with the 50 wolves. Let's say it's starting right now, 2014. And let's say that now, though, we have 500 wolves by now. Now, the cool part about doing it with a year as your sub number, instead of u sub 1 or u sub 0, we're using u sub 2014, is that now, everybody quit out of this. Remember, we had 500 wolves to start with. If you hadn't already changed yours to 500, it won't work out right now. But u is right above the 7. Everybody put in a u sub, let's say in the year 2030, 2030. So our 500 wolves, if they keep growing by 25% per year, 17,763. And the really scary part is watching the 0.56 of a wolf running around, because those things are vicious. Okay. Depends on which half of the wolf, of course, you get, but all right, anyway. So in the year 2030, do you see how we might have a problem with wolves? It'd be like, you know, stealing your dog off the backyard and stuff. So we already actually have that problem. Do you know that? With coyotes. My next door neighbor's cat, gone. The neighbor next to that, his cat, his last 2 cats, gone. One of them he had to hear, too. Middle of the night in the summertime, his window was open because it was nice and warm outside. All of a sudden he hears his cat being eaten by a coyote. You didn't go out there. I would have gone out there, even though it seems a little scary, but coyotes are small little things. They would be, you know, scared of you. I would have gone out there after it, but anyway. Not that I would have been able to stop it. By then, it probably was all over with. But anyway, he says he's going to put a one of those little GPS tracking tags on his next cat so that he can at least find out where it ends up. So that if it hauls it off into the woods and eats it, he'll at least know where the lair of the coyote is. All right, anyway. So I think we've covered most of what we need to cover here to make sure you're able to handle these problems. I want to give you a new problem from the start, so everybody go back to your y equals. And now I'm going to give you the problem parameters, and then you change your calculator to match it. In the year 2010, your great Aunt Tilly left you $1 million. Your parents never told you about it because they didn't want you to grow up all rich, snooty, kind of, I've got $1 million in the bank account, and it might affect your brain, so they decided, you know what, we're going to not tell you about the $1 million in your bank account. But it's been there since the year 2010, so to keep you from having a bad attitude, they just told you now that you had it. And the question is, if it's been growing at the stock market's average over the last few years of, let's say, I think in the last few years, it's actually been pretty good years for the stock market. We're going to go with 23% average growth. 23% average We had 1 year where it was up 60%, so I'm thinking on average over the last 4 years or so, it might have been like, all right, if you've had 23% growth on that $1 million since the year 2010, then what is it currently worth in the year 2014? Okay, so first of all, the problem started in 2010. Then I go down here, and I change this one to say 1 plus, as in growth of, what did I say, what percent? 23%, okay? Then it was a starting amount of $1 million. Then, how do I find out what I have in the current year 2014? I would personally do it this way. I'd quit out, clear this, and go U, which is right above the 7, sub 2014. Some of you might have used the chart. That would work, but then the chart, you have to set the table settings so the chart starts in the year 2014. Otherwise, you'll be hitting the down arrow 5,000 times to get your answer. There we go. Your 1 million has now grown to 2.28 million. So almost 2,300,000. Okay. Let's say, sadly, can you imagine how awful this would be? Your parents invested the $1 million in some stock that has just plummeted since then. And so let's go back and just change the same scenario to decay rate of it's gone down 20% per year. Down 20% per year. So I'm going to go over to this, and I'm going to go minus 0.20. So now you sub 2014. Holy crap, they lost over half your money. Wouldn't that be depressing? If I were mom and dad, I would probably just say, hey, good news, your Aunt Tilly left you $400,000. Anyway. Okay, so I'm going to go back to the y equals thing here and say, let's just say I don't tell you what year the problem started, but it's a real world problem. Then what should you do? If I don't tell you what year it started, you'd put a 0 right here. Real world problems, it's best to start with a 0. Then, when I ask you, how much was the 1 million worth 3 years later, do you get how when you go out here, you would say U sub 3 for 3 years later? See what I mean? It all depends on how you start. And after 3 years, it would have only dropped to 512,000. Okay. So now, let's go back to this thing. Are there any questions that you have about this whole 1 plus or 1 minus? That's growth versus decay. This is the main new thing for right now. Anything you want to ask about that? Okay, in the work time, feel free to ask me one-on-one questions, but let's jump to the homework then. Everybody find the homework worksheet. Yes, we still have to grade the old homework, but for right now, just get to the new homework. The new homework looks like this. I'm going to tell you right now, I'm going to allow you to skip problems 4C and 5C. 4C and 5C, because it felt a little long. It's not really too long, but I had a much longer lesson in the other hour, and I had to let them skip it, so I'm letting you skip it. Okay, so now, common ratio. Common ratio, a ratio means fraction, right? So we just have to make a fraction out of this to see what it is. If you take the 150 divided by the 100, you're doing it in the right order. You want to take the second one and divide by the first one. Do we even need a calculator to do this? I don't. Can you do that in your head? Divide by 100? Just know what to do? Just move the decimal over, right? How far? 2 spots. So final answer? 1.5. That is the common ratio. Do you get that that's the exact same thing as saying 1 plus 0.5? Now, you don't have to write it that way, but I want you to think about it that way, because when they ask you what is the growth rate, it is not 150%. See, people screw that up. If they have this number, they think it's 150% growth. It's not. What growth is it? 0.5, which is also known as what percent? 50% growth. See, this way is better because it will keep you from thinking it's 150% growth. It's only 50% growth. That's still a lot of growth. If you have 50% growth on your money, that would be fantastic. Unfortunately, lately in our country, it's like how much percent of debt we're going into. We owe trillions and trillions of dollars. They've actually got it figured out per person in the United States, or per household. You know, and it's like $125,000 of debt per household just over the last, like, while you've been alive. That's how much extra debt our country has gone into. Another depressing thought, out of every dollar the United States spends, we're borrowing 40 cents of it. Out of every dollar we spend on whatever it is, we're borrowing 40 cents of that dollar. And that's going on the debt, which you guys will have to pay back someday. So, all right, happy thought. Common ratio, I'm taking this, dividing by that. Wait, that's not 2 terms, sorry. This, and dividing by that. And that one is going to be a decimal. It's smaller than it used to be. Somebody already divide that? What is it? Point something. 0.4. Now, if you say the common ratio is 0.4, you are correct. The way I'd want you to write that, though, is it decay of 40%? No. That's really a 1 minus 0.6, and that'll keep you thinking right. That's decay of 60%. Get the difference? This was smarter. Because if you just say 0.4, then later when they ask you for the percentage change, a lot of kids are going to say, oh, 40%? Wrong. If it's a 0.4 factor, then it's like 1 minus 0.6, and therefore it's 60% decay. So if I were you, I'd write them all like this, as a 1 plus something or a 1 minus something. Let's do one more. Somebody must have done this one. It's like 2% growth or something like that. What did you get? 1.03? Thank you. Then that's 1 plus 0.03. That's smarter, because then you won't say it's 103% growth. It's only 3% growth. All right. Down here, they're just asking about those same 4 questions you do up above. And what is the percent change? Well, like we were looking at this one right here, the second problem, which is this one right here, and that is not 40% change. It is decay of 60%. All right. Now, down here in the next section, number 3, it says write a recursive formula for each sequence and find the 10th term. It says use u sub 1 for the first term given. You know why u sub 1 is a smart call? Because if they're going to ask you for the 10th term, then you should start with a 1. Because then you can count and say the second term is u sub 2, the third term is u sub 3. It makes sense that way. This is not a real world problem. It's about finding the 10th term. In a real world problem, I'd use u sub 0. Okay, so I'm supposed to use u sub 1. u1 equals, and again, this is going back to the first problem right here. My first term was 100. un equals un minus 1. And then this one was, let me think, that was growth. This one was 1 plus 0.5. 0.50 or 0.5 is the same thing. So I go 1 plus 0.5. Could you say 1.5? Yes, I'd accept it, but it's smarter to put 1 plus 0.5. Then the last thing, and I really didn't talk about this too much, but it's important. You need something called a domain. You may have seen this on the keys. N greater than or equal to 2. It's always n greater than or equal to, and then this number 2 is always 1 bigger than whatever you started with. So if we had started with a 0, we'd say 1. And since in this problem we started with a 1, we say 2. If you had said U sub 2014, because it was a real world problem starting in the year 2014, you would say n is greater than or equal to 2015. It's always 1 bigger than that number. That domain will cost you half a point if you don't have it on the tests. So be careful. I didn't stress it very much because this isn't necessary for the calculator, because the calculator automatically knows the domain, but it's important to write into a formula. Domains are something that get to be a big deal next year in pre-calc. Those formulas are only as good as the numbers you can plug into them. And if your formula only works in a certain place, then you have to say that on your formula, that it has a domain. All right, I think I've got you started well enough. Remember, you could skip problems 4C and 5C, and that's all I got for the video for today.